So we looked at finding a hypothesis test for a population mean when we knew the standard deviation of the population. But if we don't know that, which most of the time we wouldn't, we can't use a z-score. We have to use a t-score instead. That just means on our calculator, we're going to choose t-test instead of z-test. That's the big difference. So let's take a look at this one. Generic drugs are lower cost substitutes for brand name drugs. Before a generic drug can be sold in the United States, it must be tested and found to perform equivalent to the brand name product. So the FDA is now supervising the testing of a new generic antifungal ointment. The brand name ointment is known to deliver a mean of 3.5 micrograms of active ingredients to each square centimeter of skin. As part of the testing, 7 subjects were applied. 6 hours later, they checked it, and here are the amounts. How strong is the evidence that the mean amount differs from 3.5 micrograms? So let's talk about our null and alternative hypothesis. Differs from 3.5. That means our alternative is that the mean is not 3.5 micrograms. That would mean our null is that it is. So let's verify some conditions. Do we have a random sample? We're going to assume it is. Normal distribution, or is the sample size large enough? Well, there's only 7. So the sample size is not large enough. So we're going to need to check for normality. But one good thing is with a t-test, we are not as concerned about size or normality as we are with a z-test. So we are going to need to do some work here. We need to enter that data. So I'm going to go to the statistics menu and enter in the data. Now, I could look at the histogram, but you can't tell much with this few pieces of data. So I'm going to look at the box plot. Now, the box plot shows me a lot more. That is really normally distributed. So great. Perfect. It fits. Now, to run the test, I need to know some stuff. So since we don't know the population standard deviation, we are going to need our sample mean, our sample standard deviation, and our sample size. Well, sample size is easy. That's 7. I'm going to go to the stats feature. And let's see, number of data points, 7. Cool. Mean, 2.943. I'll go 3 decimal places. Now, this standard deviation is an approximation of the population. We don't want that. So keep going, keep going, keep going. There, it says sample standard deviation. Cool. That's 0.4995. Wonderful. That's what I'm going to use in the test. So let's go to inference. We're running a test about a mean. And we don't know the population standard deviation, so we're choosing t-test. Now, our null hypothesis is that it equals 3.5. Our alternative is that it's not equal to 3.5. Our sample mean was 2.943. Our sample standard deviation is 0.4995. And our sample size is 7. Let's double check our significance level. Ooh, 0.01. Okay, so I need to change that. And we're going to go to next. This time, my test statistic is a T. So my test statistic is a T-score. And that seems like a pretty big number. Let's see if it's big enough. Our p-value needs to be small, but is it small enough? If I compare that p-score to my level of significance of 0.01, is it small enough? Well, let's see what the calculator says. Nope, not small enough. P is bigger than alpha, so we cannot reject the null. We fail to reject the null. If we fail to reject the null, that means there is not enough evidence to conclude that the mean amount differs from 3.5. Whoops, you can't see that. 3.5 micrograms. Let's look at another example. Let's see. We'll do this one. A computer software vendor claims that a new version of their operating system will crash less than 6 times per year on average. A system administrator installs the operating system on a random sample of 41 computers. Cool, large enough. At the end of the year, the sample mean number of crashes is 7.1, and the standard deviation is 3.6. So notice that that's talking about that sample. That means N is 41. Can you conclude the vendor's claim is false? So let's talk about what their claim was. The claim is that the new version will crash less than 6 times, so that the mean is less than 6. That's the claim. That means the alternative is that it crashes 6 times. So we're going to go back. The null hypothesis is 6, and the claim is that it's less than 6. Our sample mean is 7.1, standard deviation 3.6, sample size 41, and this one is at an alpha of 0.05. All right, my test statistic is 1.96. My p-value is 0.97. That's really big. P is definitely bigger than alpha. So we fail to reject. Can we conclude that the vendor's claim is false? Yeah, there's not enough evidence to back it up. There is not enough evidence. For the claim to be true. I'll do one more example. Papa John's claims that they can deliver a pizza within a delivery area in 30 minutes or less. 35 deliveries are randomly selected. Cool. And a sample mean is 28.8 minutes with a standard deviation of 4.1. And there was 35 deliveries. What's my null and alternative hypothesis? So the claim is that they deliver in 30 minutes or less. So the null is that it takes 30 minutes. So I'm going to go back, change the null to 30. Less than 30, cool, good there. The mean is 28.8. 4.1 is my standard deviation. 35 is my sample size. And this one's at a 0.01 alpha. So the test statistic is negative 1.73, and my p-value is 0.046. Ooh, that's just less than, but that's okay. P is less than alpha. We will reject the null. If I reject the null, then that claim is true. There is enough evidence to support the claim. There is, this time, enough evidence to support the claim. Support the claim of delivery in 30 minutes or less.